Okay, dear students, here we have another paper which is of year 22, and paper is October November 22. So variant is 22 and year is also 22. So October 22 is the paper, and here we have the first question: state what is meant by work done. So it's a very simple definition. You can simply write that the work done is nothing but the product of force and displacement in the direction of force. So this is very important, that when you are writing this definition, so you have to mention this fact as well, that the displacement should be in the direction of the force, then your definition will complete. So it's very simple, but this is just an you can say definition. So be careful for the full definition. Then in part B, use the answer to A to determine the SI based units of power. So you know that first of all you have to write the equation of the power or definition of the power, which is nothing but work done per unit time. And you know that work done is nothing but force into displacement. So you have to use the units of all these quantities: force, displacement and time. So units of power you will write on the other side. You have to write in the same way: unit of force, unit of displacement and unit of time. Sometimes students make this mistake that they wrote here only they write here that the power is equal to unit of force and so on. So this will be a wrong equation. You have to write in complete you can say form: units of power is equal to unit of force into unit of displacement divided by unit of time. And then you already know that force is nothing but F is equal to ma, which is giving you this unit, which is kg, and here you have a the unit is meter per second square, and obviously the unit of displacement is meter. So very simply now you can mention that time is also unit of time is also known, which is second. So simply you can write kg meter square second power minus 3. So this will be the simple answer here, and I think this is the simple way. But don't make this mistake that you are writing here only power, and on the other side you are writing the equation this way, that unit of force, unit of displacement and so on. Then in C, the maximum useful output power P of a car traveling on a horizontal road is given by P is equal to V cube B, where B is the maximum speed of the car and B is constant. For the car, P is given as 84 kilowatt plus minus 5%, and B is given as 0.56 plus minus 7 in SI units. And as you know that they are only mentioning here that B is the constant, so they are just writing in this way the SI unit. They are not mentioning what is the unit. Part 1, calculate the value of V. So this is simple. You have for the formula P is equal to V power 3 into B. So just use their values. The P is 84 kilowatts, so 84 into 10 to the power 3, and B is nothing but 0.56. So what you are getting by this calculation, V is equal to 53. Of course, you have to make you can say an intermediate step as well, that V cube is equal to 84 into 10 to the power 3 divided by 0.56, and then of course the square root cube root on both sides will give you this result. So this is important that you are writing in this way, that here you have this equation, and here you have the value, here you have the cube root. So 84 into 10 to the power 3 divided by 0.56 will give you this result. And of course, as you know that V is velocity, they have already mentioned the velocity, so they have given you the unit of velocity as well, so you need not to worry about this unit, but you should uh, be careful that what quantity you are calculating, and this you can get by the unit of that quantity. Okay. Second part of this question C, determine the absolute uncertainty in the value of V. So when you want to get the absolute uncertainty, basically your target is just to get del V, absolute uncertainty in the value of V. So del V you need, but how you can get this? Simply you can say that we are writing the formula in this way, that here we have V cube is equal to P divided by B, but you know that when you are getting writing the equation for uncertainty, you should write in this way that 3 any power is coming first as a coefficient, then del V over V into 100 you can write, and on the other side del P over P into 100 plus del B over B into 100. Now remember one thing, that in this particular problem you can see that this whole part is basically the percentage in P, and this is the percentage in B, which they have given you directly. So you need not to worry about this, or you need not to calculate this. Be careful, you will not use this value of 84 and 0.56 here. And why? Because this whole value you have in the data. So what is the value of uncertainty in P? 5 here. And what is the uncertainty in B? 7. You can recall also that whenever you have this, you can say like ratio or the product, the formula will remain the same. Yani the formula will be in this way, that percentage of V, yani 3% of V will be equal to percentage of power plus percentage of B. So they have given you actually this these values 5 and 7. So you are getting these values over here, and ultimately you can write that the value is 12, but when you will actually write del V, so what you have to do, take this 3V and 100 on the other side, and this is how you are calculating. So ultimately what you are getting, plus minus 2, this is the value of del V, which is nothing but absolute uncertainty in the value of V. Actually here in this step you have a simple calculation, yani you have to make del V your subject, and the rest is the simple mathematics, and the value which you are getting is plus minus 2. So this is how you will calculate this part of the problem. Okay, then question number 2. A spherical balloon is filled with a fixed mass of a gas. A small block is connected by a string to the balloon as shown in figure 2.1. Here you have the figure. The block is held on ground by external force so that the string is vertical. The density of the air surrounding the balloon is this one. Density is given. The upthrust acting on the balloon is given. You can write here U. Of course, this is your density, so rho is here. The upthrust acting on the string and block is negligible. They are just mentioning that the upthrust here acting on the string and the block is negligible. Only they have given you the upthrust acting on the balloon's value. By using the Archimedes principle, calculate the radius r of the balloon. So first thing which you have to mention here, that what is actually the upthrust, or what will be the value of upthrust. So simply you can say upthrust is nothing but equal to the weight of the fluid displaced by the balloon, and this is basically coming from the definition. And if you are interested in detail, you can go to my lecture on upthrust, and of course you can follow the you can say channel and you can get the theoretical part of this upthrust thing. So weight is nothing but mg, and you know that m is nothing but rho into v. So you are getting the value, the equation for upthrust, which is rho vg. Over here you know that they have they given you the radius, so you have to change this volume thing. 4 over 3 pi r cube is the formula for your spherical body or balloon, and g of course is the acceleration due to gravity. They have given you here the upthrust, density is given, g is already here, and when you will do the calculation for r, you will get this result, which is 0.11. So I think it's better that you should try yourself the calculation and just verify that whatever I have written here is okay or not. So this is how you will get this concept, but you can consider only this part as well, because here I have developed this formula. So if you already have this concept, you can directly use this formula that upthrust is nothing but rho Vg, because marks are only 2 marks for this question. Then in part B, the total weight of the balloon string and block is 0.053 Newton. The external force holding the block on the ground is removed so that the released block is lifted vertically upwards by the balloon. Calculate the acceleration of the block immediately after it is released. So basically we have to recall that the formula is nothing but F is equal to ma, but this F is resultant force. So first we need this resultant force, and how we can get this resultant force? Simply you can say the upthrust is upward and the weight of the system is the downward force. So the resultant force, of course, the upward force, which is nothing but F, and we are getting this value 0.018 when we will subtract the value of weight by from the your upthrusting. Then in the second step, you know that what is the mass of the system. So system means the balloon and everything. So here you have this weight is given, and of course 9.8 you can use to get the mass of the system. Ultimately, as I said, that here you have A is equal to F is equal to ma. So A is nothing but equal to F over m. So you are using this equation here, and both of these values you have already calculated, 0.018, and over here you have 5.4 into 10 to the power minus 3. So the calculation will give you 3.33. I hope it's simple, but remember one thing, that as you have here 3 marks, so you better use all these 3 steps. Then in part C, the balloon continues to lift the block. The string breaks as the block is moving vertically upwards with a speed of 1.14. So here you have the speed 1.14. After the string breaks, the detached block briefly continues moving upwards before falling vertically downwards to the ground. The block hits the ground with the speed of 3.6 meter per second. Assume that the air resistance on the block is negligible. Part 1. By considering the motion of the block after the string breaks, calculate the height of the block above the ground when the strings break. So simple thing is that the equation we know, third equation of motion is 2as is equal to v square minus u square, and all these values are given, like this 3.6 is given here, and the initial velocity is 1.4. So ultimately you can use this formula, and you are getting this height, which is nothing but 0.56. I think it's simple, and here you have this value. Then the second part of this question, the string breaks at time t is equal to 0. Time t is equal to 0, and the block hits the ground at time t is equal to capital T. So this is the point, this is the time where you can say the block hits the ground. On figure 2.2, sketch a graph to show the variation of the velocity v of the block with time t is equal to 0 to time t is equal to t. Numerical values of t are not required. Assume that v is positive in the upward direction. So actually it's very simple to understand that they are mentioning here numerical values are not required, but of course you have already you can say they have given you these values. So if 1.14 is the velocity initial value which is upward, and as they have mentioned that this is the positive direction, so you can take this point over here that at time t is equal to 0, this is your time, this is your velocity which is v, and then what will happen ultimately when you are getting this capital T thing. So time is of course t here, and the velocity is the final velocity which you are taking as negative, so this is negative 3.6. So simple thing is that you can recall the situation that the slope of vt graph is nothing but acceleration. So the acceleration is always constant, and the simple thing is that they are mentioning here that the string breaks at time t is equal to 0, and the block hits the ground at time t is equal to capital T. So you need to draw a straight line simply. Actually this it's not required, but just to give you idea that the slope of the graph is acceleration of the body. So this is what we have as far as the this part of this question is concerned, and of course this is the second question. Now you are moving to the third question, and I think this question belongs to the topic moment. So question 3 in part A, state what is meant by the center of gravity on the object. So this is the simple definition of the center of gravity, and what we have written here is very simple: the point where the weight of the body is assumed to act. So be careful that whenever you are writing the definition of the center of gravity, this word assumed is very important, because of course you know that the center of gravity is not the point which is the point we are considering, but we are considering, or we are assuming that this point is the point where the whole weight of the body acts. So be careful of this part, or this word basically assumed. In part B, a uniform beam AB that is attached by a frictionless hinge to a vertical wall at the end A. Here you have the hinge, the beam is held so that it is horizontal by a metal wire CD as shown in figure 3.1. So here you have this string here or wire which is in between point B and C and D. Here you have D, and then what they are saying, the beam is of length 0.96 meter. So complete length from this point to point B, yani point A to point B, the length is 0.96, and the weight of the beam is 23 Newton. So this is 23 Newton at the center. Be careful that when we are talking about the uniform beam, this is very, very important to remember that whenever you will see this term uniform, you will consider that the weight acting at the center. So uniform is a very important term whenever you are dealing with beams or rods or something like that. Okay, a block of weight W rests on the beam at a distance of 0.20 meter from B. So here you have this weight which is at a distance of this one, and here you have this distance 0. Here you have 0.20. The wire is attached to the beam at point D. Here you have, which is a distance of 0.40 meter from B. So this distance is given, this distance for block is given, and what they are saying from the B, the wire exerts a force on the beam of 45 Newton. So this force in the wire or by the wire is 45 at the angle 37. Here you this is angle to the horizontal. The beam is in equilibrium. So you know that when the beam is in equilibrium, your two conditions of equilibrium you can use for the calculation. But for the time being, what they are saying, what they are asking in the first part, calculate the vertical component of the force exerted by the wire on the beam. So what actually you have to do, just take the vertical component over here. This is the vertical component of your force. So this is Fy, and Fy you know is nothing but F sine theta. Again, if you need the explanation of this equation, you have to go back to the lectures which I have already uploaded, and this is the y component of the vector, which is in this case a force. So Fy is equal to F sine theta, and when you will use these values, you will get the value of Fy vertical component. Here, of course, as you have the two significant figures, so the answer should be in two significant figure, and you know that it is only of 1 marks. So it's very simple. You can directly even write this part, that Fy is equal to 45 sine 37, but it's good to have this equation as well. So if you will have like a competition with other students, you will get a better you can say marks if you have a situation like you are getting a position. So if you are getting a position and you have a competition with the other student, so of course they will compare that what you have written and what the other students have written. So you will get a extra benefit of writing Fy is equal to F sine theta. Next part, by taking moment about A, yani pivot, of course, what you have to do, calculate the weight of the block. So you know that anti-clockwise moment is equal to the clockwise moment, and very simply you can say that we have two forces, W and this W, yani weight of beam and weight of the block, and both of these forces are giving you the clockwise moment, but on the other hand this Fy is giving you anti-clockwise moment. So here you have the Fy is equal to Fy into 0.56 is equal to Wb into 0.48. Be careful when you are considering the Wb, yani beam, this will be the only distance, this will be the only distance. But when you will consider the weight, you have to be careful that we are considering not only this distance, but the distance will be from point A to our weight, which is of course not 0.56 but 0.76. So these are the values you have to take care of, and then simply you have these values, just multiply these values, and of course this is something which is 23 WB, and you are just multiplying these values and getting this 11.04, and then ultimately 0.76 into W will give you this value ultimately, which is the weight of the block. So be careful of this clockwise and anti-clockwise moment, and I think it's very simple, because simply you can say that here you have have a line here, which is the line giving you the concept of your vertical distances. As I in the last lecture I have discussed this thing, that you need to draw these vertical lines, and this will help you to get the you can say distance between, or vertical distance between the force and the pivot. So this is very important. Just draw these lines, and accordingly you will get the distances. Like here you have one distance, which is distance between the pivot and the weight, and here you have another distance, which is B and weight, and then you have another distance which is between your A and the pivot. So all these things are very important. So be careful of perpendicular distance or distances. In the third part of this question, the hinge exerts a force on the beam at end A. So what is the situation? Here you have the hinge. So force, here you have this force basically, and what they are saying, calculate the horizontal component of this force. So you need to know that if you have this force, this is your you can say Fx or equal to Fx, and here you have the force, or rather I can write here like Rx, reaction force, and this is the x component of the reaction. Here you have y component of the reaction, but as they are asking here, the hinge exerted the horizontal component of this force, any force by the hinge. So this is R, you can say the reaction force, and this is equal to Rx. which is nothing but equal to your this force, which is Fx. So be careful that I am writing in this way, that this is Rx, which is equal to Fx, and ultimately you know that Fx is equal to F cos theta. So the value you are getting is 35.9, and simply you can say that horizontal component is nothing but 36. So again, be careful that they are asking here the x component of the reaction force. So I am just taking this as Rx, which will be equal to Fx, any x component of your force, this force which is in the wire. And why? Because there is no movement along x-axis. So Rx will be equal to Fx. So that's why we have calculated this Fx, which is nothing but Rx, or Rx, which is nothing but Fx. I think this point is clear. The block is now placed closer to point D on the block. So now what we are doing, we are taking the block to a new position, and here we have changed the position closer to this one, to D. And then what? Here you have this part closer to on the beam. State whether this change will increase, decrease, or have no effect on the tension in the wire. So I think again this is very simple thing, that when the clockwise movement and anti-clockwise movement you will see. So simply you can say, as the clockwise movement decreases, so of course the tension in the wire will also decreases. So this is very, very important to remember, that how you can answer this question, and it's very logical. In part 5, the stress in the wire is given. You know that stress is actually the topic of your deformation, which is sigma. The wire is now placed by a second wire that has a radius which is 3 times greater than that of the original wire. The tension in the wire is unchanged. Any tension there is no change in the tension. Calculate the stress in the second wire. So this is again, as I said, that basically you have the formula according to definition of the stress, that this is nothing but force per unit area, and force in this case is tension. So tension per unit area you can write, but as the tension in the wire they have mentioned here is unchanged, so T is same for both the cases. So simply you can write this formula in this way, that stress 1 into A1 is equal to stress 2 into A2. Stress 1 they have given, area is A1, in this case stress 2 is required, A2 you can write, but you know that area is nothing but pi r cube, and when you are calculating this thing you are getting this value. So this is what we have, and the formula which you are using here is as I said, here you have a sort of comparison, and the area is giving us pi r cube for this wire, and ultimately you are getting this value, which is nothing but the value for the new stress. So this is what you have, 5.9 into 10 raised to power 6, and here you have the value, the unit, which is Pascal, and you can also write in terms of Newton per meter square. So this is important. Okay, so this is something which is for your new stress. Calculate the stress in the second wire. Now question 4. A horizontal spring is fixed at one end. The block is pushed against the other end of the spring so that the spring is compressed as shown in figure. So here you have the compressed spring. Here you have the block, frictionless surface. The block is released and accelerates along a horizontal frictionless surface as the spring returns to its original length. The block leaves the end of the spring with the speed of this much as shown in figure 4.2. So what is happening? Here you have the speed 2.3 into your meter per second. Block is leaving the spring. So what is happening again? The block has a mass of 250 gram mass they have given, and the spring constant is 420 Newton per meter. Assume that the spring always obeys Hooke's law, and that all the elastic potential energy of the spring is transferred to the kinetic energy of the block. Calculate the kinetic energy of the block as it leaves the spring. So simple thing is that kinetic energy is nothing but half mv square, and you can change this 250 into gram into kg by dividing it by 1000, and 2.3 is the value of the velocity given here. So when you will get the calculation, you will do the calculation, you will get this answer 0.66 joules. Now what they are saying, calculate the compression of the spring immediately before the block is released. So at one point the block was compressed, and of course at one point it's released. And what they have said already here, that the all the elastic potential energy of the spring is transferred into the kinetic energy. Kinetic energy we have calculated, so what we can say that the elastic energy or potential energy is equal to kinetic energy of the block. For elastic potential energy, you know that this is half k square, and kinetic energy you have already calculated. Value of k they have given you, and you can get the value of the compression, which is basically here you are using E, which is normally we use for extension, but this is compression as well, any change in length. Basically this is the change in length. Excuse me. So this is what you have, and here you have 0.056, and I think it's clear that at this point when you have the compressed spring, the of course you have the elastic potential energy, and when the body is going back or the block is leaving the spring is changing its position, giving the velocity to the block, and of course the kinetic energy your block is getting, which is they have mentioned here that the elastic potential energy is equal to the kinetic energy. On this information you are just calculating the part B of this question. In part C, after leaving the spring, the block moves along the surface until it hits a barrier at a speed of 2.3 meter per second. So what is happening? You have over here somewhere here, suppose you have suppose you will hit this support, and then of course what will happen, you will you can say have a sort of rebound situation. The block then rebounds at a speed of 1.5 meter per second and moves back along its original path. Yani the block is coming here, and after the collision it is going back. So this is the situation over here of the block. The block is in contact with the barrier for a time of 0.086 second. So this is your barrier here. For a very small interval of time, the block is in contact over here, and then of course its momentum changes. So you have to recall that basically the value of your velocity is initial velocity is 2.3, and then what is happening, the rebound with the 1.5, and this is the situation over here, that final velocity minus, you can write in this way, that if you want to write the change in momentum, this will be VB minus UB, but here you have the situation that velocity is negative, so you can write in this way. Or if you want to get the value only, you can write here in this way, that M, simply you can add these two velocities. So remember this thing, that if you have the collision, which is elastic collision, so you can directly write the formula for change in momentum like this, M into V plus U. So when you will use this formula directly, of course the change of your mass from gram to kilogram and these velocities you have, so ultimately you are getting the value of the change of momentum 0.96 Newton second. So remember this thing, that this is the change in momentum, and the change in any quantity will have the same unit as that of the quantity. So momentum is Newton second, so you can say that the change in momentum will also be Newton second. Now what they are asking in part 2, the average resultant force exerted on the block during the collision. So simply you have to recall that the force exerted on the block is nothing but rate of change of momentum. So F is equal to mv plus u, the change in momentum, divided by time. So what you have done already, the 0.95 is the change in momentum, 0.086 is the time interval, or you can say the time of contact. So when you will use, or basically this is the time where for which you can say the momentum is changing. So this is how you can calculate the average force, resultant force, which is nothing but 11 Newton. So again the same thing, as mark is only 1 mark, so directly you can use this formula that force exerted on the block is nothing but rate of change of momentum. Force you have change, you have already calculated, time you have here, and just use the formula and get the result. In part D, the maximum compression X of the spring is now varied in order to vary the kinetic energy Ek of the block as it leaves the spring. Assume that all the elastic potential energy in the spring is always transferred to the kinetic energy of the block. On figure 4.3, sketch a graph to show the variation with X of Ek. So here you have X and here you have along y-axis you have Ek. What you have already mentioned that the elastic potential energy is completely changing into kinetic energy. So simply you can say that here you have Ek is equal to half Ke square, which is basically nothing but the elastic potential energy. So the relation is in between Ek and E square, or simply the graph is like this one, y is equal to x square. So this will be the behavior of the graph. It will start and increasing the gradient, you will have the line over here. So again here you have 1 mark, but be careful that the graph is not a straight line but it is a curve, and the graph is following y is equal to x square thing. So Ek is directly proportional to E square, and you are getting this graph. I think it's clear. And as I said that the point again is that assume that all the elastic potential energy in the spring always transfer to the kinetic energy of the block. This is the point on the basis of which we have to draw all this you can say conclusions, and ultimately we are getting this graph. Okay, so this is the question number 4 of this 22 October November 22 variant 22 of October number, of course. Then we have question 5, part A. Two progressive sound waves meet to form a stationary wave. This is the basic information. The two waves have the same amplitude, wavelength, frequency and speed. State the other condition that must be fulfilled by the two waves in order for them to produce the stationary wave. So you know that if you have to get a stationary wave, you will have two waves which will move in the opposite direction, and when they will superpose each other, you will get the stationary wave. So simply you can say that the first answer is nothing but, simply you can write two waves travel in opposite direction. This will be another condition for you can say the stationary wave. Now in part B, a stationary wave is formed on a string that is stretched between two fixed points A and B. Figure 5.1 shows the string at time t is equal to 0. So this is the basic diagram, you can say, as I have already drawn, so you need not to get confused, but this is the basic diagram. And what you have here, they are mentioning that between point A and B you have a stationary wave with in figure 5.1 shows the string at time t is equal to 0. Yani when you are starting your stopwatch, I can say this is the position of your string. When each point is its maximum displacement, you know that when you have the stationary wave, the situation like this you will have. And here suppose you have the string, so when you will disturb the string and something like this you are getting, so this is the position where your string is at time is equal to 0. So when time will pass like t over 4, the string will go in this direction and in this direction and in this direction. So this is the situation here. Distance AB is 0.80. The period of the stationary wave is 0.016 second. So what we have to do in part 1 on figure 5.1 is sketch a solid line to show the position of the string at time is equal to 0.004 second. So you have to be careful that when you will have the situation of this 0.004 second, so you know that if the time period is 0.016 second, so what time has been passed? So 1.5 second has passed. So what you can say that at this point, like here you have 1/4 time, then here again you have 1/4 time, then it's coming back, then it's going up, and then it's coming back. So what will happen in 1.5, the line, the whole string you can say will be in the form of a line, a straight line, because each and every particle will be in the form of a straight line. So this is the time 1.5. So be careful of this situation. And then what you have at time 0.024 second. So what is the situation here? Here you have 0.024. So when you will get this 0.024, basically this is the point over here, Q. This is point Q actually, and this is point P. So for P you have this situation that here you have only 1/4. So basically for time t 1/4, this is not 1.5. 1.5 is something different. Here you have actually this point P, which is for, here you will have for P. So this is your P, and when you will have this situation of 1.5, so what you will have, 1.5 means 0.024 divided by 0.016, 1.5. Be careful. This is P. This P is here because only 0.5 has gone. So 0.5, here you have T over 4. This is T over 4 and so on. But 1.5, so what is the situation here? For 1.5, you can simply say that this is our T by 4. This is your T half. Then you are coming back and again coming somewhere here and then going back. So 1.5 is the position of this string somewhere here. So be careful that 1.5 you will be in this new position, but this will be the simply your mirror image of the given position of the string. So P is straight line where you have only T over 4, and for 1.5 you will have this new position, and this is the mirror image of your string. I hope it's clear. So this is P, position P, and this is for position Q. Determine the speed of a progressive wave along the string. So what you have to do, you must remember that when you will have this situation, simply you can say that here you have nodes, and in between the nodes you will have the distance, which is nothing but lambda by 2. So how many nodes you have? 1, 2, 3, 4, 5. So this is lambda by 2, lambda by 2, lambda by 2, lambda by 2, which is equal to length. And of course you will get the value of lambda by using this length which they have given here, which is 0.80. So lambda is nothing but 0.40. Of course meter is the unit here, and when you will use the formula V is equal to F lambda, you know that F is nothing but 1 over T, any reciprocal of the time period. They have given you here the time period, so you are just using this value. Lambda you have calculated, so ultimately you are getting the frequency, speed, which is nothing but 25 meter per second. So be careful. I hope it's clear. Then in part C, we have a question based on polarization of the light, and here you have the question: a beam of vertically polarized light of intensity I0. So here I0 is incident normally on a polarizing filter that has its transmission axis at 30 degree to the vertical as shown in figure. So what is happening? Here you have the vertically polarized light, and basically you have to recall that what is an unpolarized light. So unpolarized light is something which has light in all planes. So but when you will have the vertically polarized, so what will happen? All other parts of the light will be absorbed by something, and only this is the vertically polarized part of the light, you can say, which is coming as the intensity I naught. Here you have the situation of the polarizing filter with transmission axis at 30 degree to the vertical. So if you have this vertical, this is 30 degree, and then what is happening over here, the beam is just passing through, and now you are getting another beam which is transmitted beam, and the intensity is I1. The transmitted, here you have the transmitted light from the first polarizing filter as intensity I1. This is what we have. This light is then incident normally on a second polarizing filter that has its transmission axis at 90 degree to the vertical. So this is what we have, 90 degree angle over here. This is the situation for the second polarizing filter. The transmitted light from the second filter has intensity I2. So it has further decreased in intensity, you can say. What is the ratio? Calculate the ratio I over I naught, yani ratio of these two, I naught and I1, I1 over I naught. So remember this formula that I1, the new intensity, is equal to or will be equal to the previous one, the intensity previous one, and cos square theta. So when you need to calculate I over I naught, simply you can say cos square theta will give us the result, which is nothing but 0.75. On the other hand, ratio I naught, I2 and I naught, so this is I2 and I naught. So what you can write, first of all, you can say that two consecutive intensities, I2 and I1, we have to consider. So I2 is equal to I1 cos square theta. And you know that the I1, if you want to get the, or you want to get the result of I2 and I naught, so what you are doing, I2 divided by I naught, you have here, and actually you have divided I2 by I naught. You will have to do the same thing on the other side, so which is I1 over I naught. So you will divide this equation on both sides by I naught. In this way you will get the ratio I over I naught, which is nothing but you have already calculated. So 0.75, which is the value of I over I naught, you have already calculated, and cos square theta, yani cos square of 60 degree, is giving you 0.25. Remember this thing, that you will calculate first cos 60 degree and then take the square of that value, and you will get 0.25. Cos 60 is 0.5, and you will take the square of 0.5, you will get the value over here. So ultimately when you will use this calculation, or you will get the value 0.1876, but in two significant figures you are getting 0.19. So this is very important, and this is actually the new topic included in the syllabus. So of course you need a detail of this topic as a theory as well, but at least you should know that if we have the transmission situation, the equation like this, you will have that this is I say I naught cos square theta. This is the basic formula which we have to remember. I will be the transmitted, you can say, intensity of transmitted light, and I naught will be the original, you can say, intensity of the light, which is basically the, you can say, vertically polarized in this case. Okay, so I hope it's clear. Now question 6 says that in part A, define electric potential difference. So this is again basically this is simply the definition again. So you know that energy transferred per unit charge, energy transferred per unit charge from electrical energy to other forms of energy. When the electricity is passing through any component, this will be the situation that electrical energy will change into any other form of energy, and that energy per unit charge will give you the idea of the electric potential difference between 2 points of the component. Okay, then we have part B. What they are saying, the battery is connected to two resistors X and Y as shown in figure. The resistance of resistor X is greater than resistance of resistor Y. Yani this is simply given as Rx is greater than Ry. State and explain which resistor dissipates more power. So this is what we have to consider here, that P is equal to I square R, and obviously you can use this information to give the answer of this question. What they are saying, resistors X and Y are in series first of all, thus the current is same in both the resistors. So what you can say, that the current is same in both the resistor because they are in series. For power dissipated in resistors, you know that P is equal to I square R, or simply you can say when the current is same or constant, P is directly proportional to R. And as Rx is, as the resistance of resistor X is greater than the resistor X, dissipates more power. So simply think is that when you have this relation and you have this relation, so it's very simple to state which resistor will dissipate more power. So simply you can say that the resistor X will dissipate more power. So this is what we have. Okay, what is next? Part C. In part C, they are mentioning a battery of electromotive force 9 volt and internal resistance R is connected to two resistors P and Q as shown in figure. So what is happening actually, you can say and see that the current is coming here, and then it will divide into these two parts, and again they will meet somewhere here. So whatever the current you have here, this will be the current which is passing through the internal resistance. Let's see what they are asking. And what they are saying here, a total charge of 650 coulomb moves through the resistor P. Total charge, they have given you the charge Q which is passing through. Need not to use this Q because you have already here a Q. So simply you can use a small q for charge. So what they are saying, a small q say is this one moves through the resistor P in time interval this one 540 seconds. During this time resistor P dissipates 4800 joules of energy. The current in the resistor Q is 4.5 A. Assume that the EMF of the battery remains constant. Calculate the current in resistor P. You can use Q over T because normally we use Q for the charge, but you can even use here the small q because Q as one resistor they have given. So Q over T is equal to the total charge divided by total time. So this is what you have, simply 1.2 you are getting here, the current which is through the resistor P. Simple, I think it's very simple. And then 2, the potential difference across resistor P. So when you need to calculate the potential difference across P, what you have, P energy is equal to P into T. Remember, this is again a formula. This is a very simple formula. And when you will have this current and the you can say the power, you can write in this way that I into V into T. Power is I into V, and of course T is here. So all these values now you have. Energy is given. The current you have just calculated. You need to calculate V, and the time is already given. So when you will use all this data thing, you will get this value of your potential difference between point over here, which is nothing but these points A and B. So you are getting the potential difference between P, or for P between A and B. But remember this thing that as your Q is also connected to these same points, so you will have the same potential across your Q. But let's see what is the other part. Then what they are asking, the internal resistance R of the battery. So for internal resistance of the battery, electromotive force, and the potential difference across the any resistance, you have the simple formula: electromotive force is equal to IR. Yani you have, this is basically the potential loss in the internal resistance. So you can simply say that this is IR, internal resistance, plus potential difference. So what potential difference you have already calculated? Basically you have calculated the potential difference across P, but as I said that P and Q are in parallel, so the same potential you will have for both of them. So simply you can say that the potential difference is nothing but what we have calculated, which is 7.4. Over here you have the situation of your uh, E, which is given in your formula here, which is 9. At the same time they have given you the current in Q. So current in P you have calculated here, current in Q they have given you 4.5. So when you will consider the total current, which is in this way going towards the R, so simply you can say the total current I over here in this part of the circuit will be the sum of the current through P and through Q. So these two currents you will add to get I, and when you are just using this current, very simply you can calculate the internal resistance, which is nothing but 0.28, and this is what you are getting as the result. So internal resistance is 0.28. You can calculate yourself as well, and of course this will give you a practice as well. Last but not least, here you have the question number 7. What they are saying: describe the structure of an atom of uranium 238. So remember this thing, that whenever you will have a nucleus like uranium, suppose you have, so this is the A atomic mass, and over here you have say Z, which is nothing but proton number, and you know that proton is number and the electron number is always equal. So when they are asking for the structure of atom, simply you can say that here you have 92 protons, 92 electrons, and you know that A is equal to N plus P. So when you will use this concept, you will get the number of neutrons as well, which is nothing but 146. So 146 neutrons are present here. Then in part B, decay of uranium 238 is shown by the equation. Here you have the situation like uranium 23392 is changing into the thorium, which is 23490, and X is given. For nucleus X, calculate the ratio in coulomb per kg of charge to mass. So you need charge and you need mass. So what is the situation here? What is the charge and what is the mass? Simply you can say A is nothing but, as I said, 238 and 234. When you will subtract these two, you will get A of X. And when you will use 92 and the 90, you will get the value of your P or Z. So this is, you have 4 U, simply you can say, and this is charge, which is 2E. So when you will calculate this value, 4 into U, U is given in data sheet over here. So this is 1.66 into 10 to the power minus 27. 4, of course, you will multiply here. Charge of proton and electron is same. It is nothing but 1.6 into 10 to the power minus 19. So ultimately what you are getting, charge is has this complete value, and of course the mass is given by this value. So when you will use these values, you will get 4.8 into 10 to the power 7, which is the required ratio between the charge and mass. This is very, very important, and this of course the unit is coulomb per kg. So you better use all these steps to get complete marks, 3 marks. Then in part C, the last part of the question, I think, yes, 2 particles P and Q each consist of 3 quarks. Again, you should know that we have small particles called quarks, and we have These cogs are up and down cogs, and particles P has no overall charge. P has no charge, particle P has no overall charge, particle Q has an overall charge of plus 2e, where E is the elementary charge, so be careful. State the chord composition of P and Q. So what we actually have to recall that the up quark has a charge which is 2 over 3e, and down quark has the charge which is negative with 1 over 3e. So if you have no charge, so what actually you have to do, as I have done here, 2 over 3, 1 over 3, 1 over 3, negative negative, so they are giving you the value of 0. So charge of P is 0, so that's why you need this ratio or these ratios, and ultimately what you have, up down down. So simply you can write here up down down. This is the composition of your quark P, or even you write in this way, up down down. Similarly Q, if you have 2e, so you do something, you have to calculate something which is giving you plus 2e. So when you will write in this way, plus 2e plus 2, actually this is all e's you have, plus 2 over 3 plus 2 over 3 plus 2 over 3, so ultimately you will get plus 2, and of course ultimately you have E as well. So simply it means that when you will have this combination up up up, then you can get the charge of Q as plus 2E. So be careful, and of course this is the ultimate result of your charge. So this is your paper, which is nothing but 9702 22 October November 22. So I hope you have understood the discussion, and very soon I will upload another variant which is 2.1. I think I have already uploaded 2.3 on my channel. So if you are new on my channel, subscribe this channel, like this channel, and share with other students so they can get benefit of it. I hope you are enjoying this, but if you have any problems, you can contact me through your comments, and I think this is very very important to have a contact between teacher and student, that you should have a sort of opinion as well, and if you have any confusions, you should comment on the lecture, and of course you can contact me. I think I can give you my number here as well, so you can get the benefit of that number, and of course I think you will have a better understanding of the topics. Okay, so see you inshallah in the next discussion. Allah Hafiz.